Do you know what's common in applications like WhatsApp, Yahoo Finance, Google Docs, and Fortnite? No, it's not that they are all owned by multi-billion-dollar corporations. They all use WebSockets. We will talk about WebSockets in this video and also build a simple chat application to get our hands dirty. The goal of these kinds of applications is to send any new or changed data to the client as soon as possible. So a new message should send a notification almost instantly on your phone. The latest stock price should be updated instantly on the finance website. Any game moves should be reflected on the screens of all players almost instantly. Any change in a document by a collaborator should be shown to the reader instantly. WebSockets facilitate this instant communication between client and server. Before WebSockets, developers had to rely on HTTP polling along with technologies like AJAX, where the client repeatedly asked the server for updates. This was slow and inefficient. WebSockets changed the game by allowing persistent bi-directional communication, meaning the server could push updates to the client almost instantly without waiting for a request. WebSockets was introduced in 2008 by Michael Carter and was officially adopted in 2011. Since then, they have become a core technology in real-time update applications like chat applications, stock price updates, and multiplayer gaming. Let's visualize the flow of a HTTP request versus a WebSocket connection. In the case of a HTTP request, a new connection is established between the client and the server. The server sends a response back to the client using this connection. After the response is sent back, this connection is terminated. The server has no way to contact the client unless the client starts a new request. So every request-response cycle has this overhead of creating a new connection. In the case of WebSockets, the client requests the server to create a new WebSocket connection. On success, a persistent two-way channel is established between the client and the server. Using this channel, the client and the server can now send messages to each other instantly without the overhead of creating new connections. Now that we understand the theory of WebSockets, let's build a simple chat application using Go. Let's begin with looking at the demo first. Two users are connected to the same chat room on my server running on localhost. Because they are using WebSocket, message sent from one client is passed on to the second client instantly without using any polling, etc. The backend of this application is built in Golang and the front end is built in plain HTML and JavaScript. The design of the HTML is done using Bootstrap. Let's start with the backend. In the backend, we have the room.go routine. In this Go routine, we first create a structure room. Room has an ID to identify itself. Then it has a map of clients. Key of the map is the WebSocket connection, and the value is the name of the client. This is just to keep things simple. You can obviously create a structure called client and define it properly. Then we define a channel of type message, which we will define below in a minute. We will name it broadcast. This channel will be used to pass on the messages between different clients. After that, we define a mutex. This will be used to avoid data race conditions. So only one Go routine can write in the message channel at one time. Then we have some created at timestamp. The message structure has three properties. Type, which defines the type of the message. If it's a chat message, something like client name, info, or system message. Then the sender, who is sending this message. The sender could be one of the clients or the system. And the content of the message, which is also plain string. We will also create a map of rooms which will contain all the active rooms. And we will create a rooms mutex object to avoid data race condition on the rooms map. Now that we know how our room data model looks like, let's look at the main Go routine. In our main Go routine, we use the Chi library to create a new router. This happens in line number 13. In line number 16 and 17, I use some middleware. And in line number 22, I start my server. In line number 19, I call router.setupRouter method, which will set up my API endpoints. In the setupRouter method, I set up my API endpoints. In line number 22 till 26, I set up my standard REST API endpoints. Post on /rooms will create a room using the method createRoom, which is defined below. A get on /room/id will check for the room, and /room/id/join will join the room using the method joinRoom. From line number 28 till 30, I serve my index.html to the front end on the default endpoint. And from line number 33 till 34, I expose my static directory so that I can serve my JavaScript file to the front end. To keep the code clean and manageable, all the domain models have their own Go routine. And all the functionality pertaining to that particular domain is in that Go routine. So for example, the methods to create a room and join room are in the rooms.go Go routine. And the methods to send messages to clients is in the client Go routine. Similarly, as you can see, all the routes are defined in its own router.go Go routine. With that in mind, let's look at the create room method, which handles the post on /rooms endpoint. Let's scroll down to the create room method. In the create room function, we call the room.createRoom method in the room Go routine. On success, this method returns us the room ID. We take this room ID and send it to the front end in JSON format. Let's see what room.createRoom method does. In this method, the room ID is generated using a UUID random string. In line number 53, we remove all the minus or all the dashes to reduce the size of the string. After that, in line number 54, we lock the room's mutex, and in line number 55, we use differ to unlock the room mutex after the method finishes. Then in line number 57, we create the room object using the room ID that we just created. Everything else is basically empty, and the created at is set to the time right now. Then we add this room with the room ID as the key in the rooms map. In line number 66, we do some logging, and in line number 68, we return this room ID to the calling method, which then in turn returns it to the front end. In line number 64, we start a new Go routine, send new messages to all clients. This method starts a loop, and every time a new message comes in, we'll send this message to all the clients that are logged into the room. Because this functionality belongs to the client, this method is also defined in the client.go Go routine. Let's click on the method to see what it does. In this method, we start a never-ending for loop. In line number 12, we read any message that comes to the broadcast channel of the room. Once we get a new message, in line number 13, we log the room. In line number 14, we iterate through all the clients that are logged into the room. And in line number 15, we write the message as JSON to their connection. If there is any error in line number 16, we will close the WebSocket connection and remove the client from the room in line number 19. In line number 22, we unlock the room for further processing. Let's do a quick recap of the create room process. So when the room is created, a new UUID is generated as the ID of the room. This ID is sent to the front end. At the same time, a broadcast channel is created. Whenever a new message comes to this channel, this message is forwarded to all the clients that are logged into the room. This newly created room is also added to the rooms map that we saw in the beginning. Now that we know how a room is created and what happens when the room is created, there is a background process is started which looks for new messages, and when the new message arrives, it forwards that message to all the clients. Let's look at how a client is added to the room and what happens then. If you remember, the join room functionality was supported by the API endpoint /rooms/id/join. This endpoint is handled by the method join room. Let's go into the join room method and see what it does. In line number 67, we extract the ID of the room that we would like to join. In line number 68, we do some validation checks. For the brevity of this video, we will skip this step. Line number 77 is where the magic happens. The HTTP connection is upgraded to a WebSocket connection. In line number 80, we send an error message back to the client if there was an error upgrading the HTTP connection. If that was successful, in line number 84, we use the room.joinRoom functionality to actually join the room. Let's go in that method and see what it does. In line number 89, we validate the room. In line number 106, we get a new random client name that we will assign to the client. And in line number 110, we add this new client name with this connection as the key to the client's map in the room. After that, from line number 114 to 116, we start 3 background processes which will handle the messages. Let's look at these 3 processes one by one. Because these processes pertain to the client, they belong to the client Go module. In the first method, send client name to itself, the randomly generated client name which was generated in the join room method will be sent to the front end in JSON format. You can see that here in the front end. The next thing we would want to do is to send the name of the newly connected client to the already existing clients. This is done by the method sendClientName to other clients. Let's look at the implementation. In this method, between line number 84 and 87, the message is created. And in line number 91, we loop through all the clients in the room, and in line number 92, we skip the current client, and to the other clients we send the message in line number 95. If any of the client throws an error while sending the message, that client will be removed from the room. Of course, this is done by locking the room and unlocking in the end in line number 90 and 102. This is the message I'm talking about in the front end. Let's now look at the third and the last method, handle new message from client. This routine is started for every client that joins the room and handles the message from that client. In line number 41, an endless loop is started. In this loop, the message is read from the broadcast channel in line number 42. If there is no error reading the message, in line number 56, a message object is created, and this message is then sent to the broadcast channel in line number 63, where it will then be fetched and pushed on to all the other clients that are connected to the room. In the beginning of the method in line number 27, we use the differ function to create a function block. This block is executed when the client leaves the room. In this block, a message is created, and then this message is then also broadcasted to the channel so that all the other clients that are connected to the room get the message that a particular client has left the room. Now let's look at the front end. Instead of explaining the whole front end, I will concentrate only on the part that relates to WebSocket. This happens in JavaScript. In the method start listening for messages, in line number 67, we create a new WebSocket connection. Please note that instead of HTTP, we use the protocol WS. We call our API endpoint room/roomid/join. On success, this will return a WebSocket connection. Once we have the WebSocket connection, we can send messages to this socket. For example, in line number 90, whenever the client enters some text and hits enter, the message will be turned into JSON and then will be pushed to the broadcast channel. Similarly, when there is a new message in the broadcast channel, this will be read in line number 68, and depending on the type of the message, will be shown on different part of the GUI. And of course, if there's an error, this will be printed in the console in line number 79. That brings us to the end of the video. You will find the Git repository in the description. I hope that the theory and the demo helped the understanding of WebSockets. And now you know how easy it is to use them. If you have any questions or critique, please leave them in the comments. And don't forget to like and subscribe. Till next time.